Okay, hi, welcome back. Now we'll be talking about how ionic bonds are formed between metals and non-metals. So in ionic bonds, they are generally formed between metals and non-metals. In other words, right, you require at least a minimum of two elements. Most probably it's just involving two elements, one metal and one non-metal. So metals, they tend to be from group 1, 2, 3 of the periodic table, whereas non-metals is group 4, 5, 6, and 7. Okay. Uh, and this is usually done through the transfer of electrons, generally from the metals to non-metals. That is why we tend to actually put metals first in terms of naming, then followed by the non-metal. So when the metallic atom, right, actually lose the electron, they tend to be positively charged, and hence they are called cations. Whereas on the other hand, the non-metallic atom, they tend to gain the electron to become negatively charged. This difference in charge actually results it to form some form of electrostatic forces of attraction. And these electrostatic forces of attraction, right, um, will act something like a magnet kind of thing. So whereby unlike poles, they tend to attract to one another, and from this together, they are be able to form a giant crystal lattice structure or an ionic compound. So how are we able to draw the ionic compound? Let's say in the exam they ask you to draw the sodium chloride. First of all, as working, identify the number of elements used required, how many sodium is required to how many chloride and chlorine based on the number of electrons it lose and gain. So let's say sodium loses one. Then if let's say the non-metal, which is chlorine, requires one electron, and you would see that both when one lose one, one gains one, it tends of balance off and cancel out. This will also give you a scenario of the charge of sodium and the charge of chloride. And when you draw their when you draw them individually for sodium and chlorine actually, you would see that this itself is the answer they are looking for in terms of ionic compound. Are you required to draw these two? No, you are not required. These are working to help you, and usually you don't really have to draw the neutral atom unless they in the question they ask you. Um, However, the second question is, do I have to show only the valence electron, or must I show everything? If the exam question states specifically they want to see the full electronic structure, then you would also have to indicate the inner electron shells as well, all of it. Second thing, if they never state, you'll be highly encouraged to draw the inner shell as well. Unless they say valence electron, then you just have to draw the valence shell. Okay. Now, what is missing here is the legend. Legend represents what the symbols tell you. So the circle will be used for electrons from sodium. Then the cross will represent the electrons from chloride or chlorine atom. This is sufficient for legend. You are not required to draw like, oh, the plus minus tells you like, oh, the charge. No need. Just a dot and cross would be, the dot would be a circle of electrons from element A, then cross for element B. It is not a requirement whereby you for metals you use a circle, or non-metals you use a cross. No need. As long as you show that there are difference in electron movement based on the dot and cross, you will be okay. Okay, so magnesium, we would see that you would, because magnesium will tend to lose two electrons. So what will happen is, because you're paired with chlorine, and it will only gain one. So what happens is these two electrons, right, one of it will go to one chlorine atom, and the other will go to another chlorine atom. Eventually, this would mean that you need, for every one magnesium, you will need two chlorine. Therefore, the chemical formula is MgCl2. How are we required to draw? There is this way where you can actually draw both, all the electronic configuration or all the atoms that is given. But in this case, do remember to put the central uh, ion as the one from the metal, that means the cation, whereas the site is the anion. This might be a bit challenging because it's quite a lot of things to draw. So an easier alternative is you actually draw for just magnesium and chlorine for just one of them, and separately just write a very big 2 at the side, which is on the left hand side. Okay, this will represent that for one magnesium you require 2 chlorine ions. Okay, so this will be much more easier. Do leave some space in between so that it looks like it's you have the space to continue lah. Okay, so this is accepted. Are you required to draw the things below, the information below? Answer is no. This is sufficient. This is sufficient. Okay. Finally, we look at the chemical formulas of ionic compound. How are we able to name the ionic compound? Generally, there's a few rules. Number one, if a compound is made of 2 elements, and you will generally have a name that ends with IDE. For example, if you use chlorine in the periodic table, you end it with IDE. Oxygen, it'll be not zinc oxygen, but zinc oxide, OXIDE. Okay. Then, of course, compounds that contains a hydroxide ion, a OH minus, we tend to end it with a hydroxide. This one you will learn more in your alkalis, in the acid and base chapter. And finally, if we look at compounds containing negatively charged polyatomic ions are basically ions that is made up of 2 or more elements, okay, combined together, and they usually have a name that ends with the ATE, like sodium sulfate, copper 2 sulfate, sodium nitrate. Okay. Now, one thing to take note is you could see that all these names there is actually usually 2 words only lah. You rarely see 3 words kind of thing. And what we take note is, now I'm highlighting all the cations, which are your metals. And the ones in green are your anions. So for the structure for any naming for ionic compound, we always put the metals first, followed by the non-metals at the end, which in other words, the cation first and the anion later on. Okay. In terms of writing chemical formula, this one was naming. For the symbol wise, we tend to put the metal first, then the non-metal. The number of atoms for the specific atom, we tend to put a small 3 at the bottom right hand corner. One very common mistake is students tend to put at the top. Now, when do you put at the top? When do you put at the bottom? At the top is only for the charge. Okay, top means the superscript here. It's only for the charge. 3 is not the charge. 3 is the number of atoms that the chemical formula have. Okay, then of course superscripts are usually set to simple whole numbers. You will not see like Na4O4, that kind of thing. Usually you will simplify it. However, when you study at a later chapter, you realize that there's a difference between empirical formula versus molecular formula. Okay. We do not write the subscript 1. Usually for 1 we tend not to write. We just treat it as blank. Okay, but in terms of symbols, for the charge, we would have to write the symbol. Then, of course, if there is more than one polyatomic ion, the formula of the ion is placed within the brackets. Okay, like this. So generally, the main principle of forming the ionic compounds is to balance the charge between the positive and the negative ions, such that all the positive charge must equal to the negative charge in the ionic compound. For example, when the first step that we want to do, right, is to identify what is the group of magnesium and what is the group of the oxygen. So magnesium is group 2, and oxygen is group 6. What this means is it's easier to lose 2 electrons from magnesium, and it's easier to gain 2 electrons from oxygen. Okay, so in this case, right, we would have to then do the balancing such that how many electrons magnesium has to give away to receive to determine the number of electrons that are the number of atoms of oxygen required. And we can see since the number is the same, they tend to just cancel each other, and therefore it's MgO. Okay. If let's say I don't use oxygen, I use magnesium chloride. So magnesium is group 2, chloride is actually group 7. What we would see is that for magnesium, right, is Mg2 plus, whereas for chloride, it'll be Cl minus. Between a 2 and a 1, one shortcut is, but before the shortcut, you will give, magnesium will give 2 electrons, so you will need 2 chloride ions to receive it each. So one will receive one. Now the shortcut is we actually to convert this number and you bring off to the other side. Meaning this 2 is for this chloride, this charge is for this magnesium. And based on these, right, it will simplify it, you will still get the same chemical formula. So copper 2 hydroxide, it will be Cu2 plus, and hydroxide is OH minus. For polyatomic ion, you cannot find in the periodic table. You would have to memorize one. But of course, there's a few of them, which we will discuss in a separate lecture. For hydroxide, right, it tends to be OH minus. And for copper 2, because of the 2, they tend to be Cu2 plus. So if we want to crisscross, right, the 2 will be covered to the hydroxide, so OH2, like this. And then the copper will receive the one, so it's Cu. So this whole thing will be copper 2 hydroxide. So to balance the charge, multiply the smaller charge by 2 to make it equal to plus 2, and this would be the chemical formula. So this is the steps for what we have discussed, and we would see that eventually the switch will be this. So like for Y and M, okay, there's the M, there is the N. The M will come here, and the N will come here. Do take note that you don't have to actually write the symbol plus and minus, and this has to be a subscript, meaning from a superscript, the top part, it becomes the bottom part. Okay, just like this. So the 3 will come here, the 2 will come here, Al2O3. Same thing for calcium carbonate, because they both will receive the 2, we will not write in terms of if they can be divided or simplified, or what they say 2 is the common factor. Okay, it will be removed, and therefore you'll get calcium carbonate. Do read in the exam question what do they want. In this case, they want chemical formula, so you write the chemical formula. However, if they want you to write the chemical name rather than formula, then is calcium, you spell it out into calcium carbonate. Finally comes to the most important part, which is structure and properties. Okay. So in terms of answering such questions, when they ask you to explain in terms of the why the melting and boiling point is high or low, always follow this structure where first you describe the structure of the compound. After you have described the structure of the compound, you talk about the electrostatic forces of attraction. Is it high or low? Then you talk about the amount of heat, energy required to overcome them, means to overcome the intermolecular force of attraction, and then you conclude with the property. Because of high amount of heat is required to overcome the forces of attraction, therefore it will have a higher melting and boiling point. So before we stick to this structure, let's look at what we meant by giant ionic structure. So giant ionic structure is also known as a giant lattice structure or crystal lattice structure. And this tends to consist of an endless repeating three-dimensional lattice of positive and negative ions. Okay, um, meaning right later on there is a structure we will be able to take a look. And because of this, they are very closely packed as they are the charge will actually just attach each other, and therefore they are always arranged in an orderly manner and held in place by ionic bonds. So what we can see is over here for sodium chloride, which is an ionic compound, the sodium is the metal, therefore it's a cation. Whereas the chloride comes from a non-metal, and therefore it tends to actually gain the electron, forming the anion. So this alternation will happen, and subsequently it will form into a three-dimensional shape, such that they will be sitting next to each other to further like attract one another. So the forces of attraction between the ions in the crystal lattice structure is actually very strong, where a large amount of energy is required to overcome these forces of attraction between the ions. You could see that the phrasing is quite consistent. So if you were to draw, the green one represents the chloride ion, and they at every one point they tend to be surrounded by 6 sodium ions. How do I get these 6? You basically can count the neighboring ion. For sodium, it's each sodium ion is then surrounded by 6 chloride ions. So you'd see that the ratio would be 1 to 1, which is similar to the chemical formula of sodium chloride. That's why ionic compounds are chemical compounds, and being chemical compounds, they would have the fixed ratio as its constituent element. So in terms of property, it will, because of all these structure in place, they actually have high melting and boiling points for ionic compound. And having high melting and boiling point, they are non-volatile. Non-volatile means that they actually become gas easily and most probably under room temperature. One example of a volatile liquid is your perfume, where you store in a bottle is in liquid, but once you actually release or spray, it tends to become vapor very quickly. Okay. Lastly, it exists as solid at under room temperature. For solubility of ionic compounds, they tend to be usually soluble in water. In what way is in a sense that they are able to dissolve in water. And when the sodium chloride they dissolve in water, right, they tend to actually break down to form water molecules. And these are usually insoluble in organic solvents. Okay, so one way to remember this of solubility of ionic compounds, can sodium chloride, your salt, you throw into water, it will dissolve immediately. And sodium chloride is an ionic compound. So anything that is like ionic compound, they tend to be able to dissolve in water. But let's say you throw it into organic solvents like petrol, oil, ethanol, it tends to not dissolve, it will just be there. Next, we look at electrical conductivity of ionic compound, and for you can see through the light bulb, right, that under the aqueous and molten state of the ionic compound, electrical current can actually pass through it because there is a complete circuit. However, for solid sodium chloride, because it is insoluble and because it is not either molten or aqueous, it results in not being able to transfer the electrical charge, and hence it will not light up. That's why uh, it is an insulator. So how do we go about explaining it? So ionic compounds, they tend to conduct electricity in the molten and aqueous state only, and they do not conduct electricity in the solid state. Why? Because in the molten and aqueous state, mobile ions are present. Ions, because you remember you have a cation and anion, they are mobile, meaning they can move around. And because they are mobile enough, they will then be able to carry the electrical charge across from one end of the compound to another end. This will then give it, the mobile ions, the ability to conduct electricity. Okay, so that's the end for ionic bonding or ionic compound. Do your revision, and I will see you in the next chapter. Thank you.